Hello learners, welcome to your favorite digital learning platform Unfold You. I am Virendra Singh, your physics mentor. Now, as I have told you in our previous session that in this session we are going to see relation between stress and strain. So that is what we are going to do in this session. We will see first what is the relation between stress and strain, and based on that relation we will derive a very important law that is called Hooke's law. Right, so let's start our discussion, and first is relation between stress and strain. So normally stress and strain, they are proportional to each other. That means in a body, if there is a stress developed inside a body, that stress will be directly proportional to strain. Right, and how they are related? They are related. Stress is proportional to strain, and to remove this proportionality sign we introduce a proportionality constant called E. Right, we introduce this proportionality constant E. Now what is this E? This E is called modulus of rigidity. This E is called modulus of rigidity or modulus of elasticity. Right, this E is called modulus of rigidity or modulus of elasticity. Right, now this relation, that stress is equal to modulus of elasticity into strain, this relation is called Hooke's law. Right, in your exams you sometimes get a 1 mark question or even a 2 mark question based on this thing, that what is Hooke's law. So Hooke's law is basically that stress is equal to modulus of elasticity multiplied by strain in a body. Right, now let's move forward and let's see more things about modulus of elasticity. So modulus of elasticity depends upon the nature of material. For sure, it is expected that this modulus of elasticity for sure has something to do with the nature of material, because we know stress and strain are something which depends on nature. Right, some bodies are going to behave in different manner and some bodies are going to behave in somewhat different manner. That means the nature of body is going to play a vital role here, and therefore this modulus of elasticity must depend on what? Nature of material we are using. Right, so it is the nature of material based on which this modulus of elasticity depends. Right, next is its value depends on temperature of the body. Now it is also expected, because we know if we increase temperature of a body, if we consider a solid body, then it tends to melt down. That means if a body has a tendency to melt down, for sure its elasticity will change. Right, for sure. So that means it is a temperature which is also going to change the modulus of elasticity. Right, now its value is independent of the dimensions of the body, and this is also expected, that if I have a wire of say 1 meter and if I have a wire of 10 meters, is the elasticity or the behavior is going to change? No. Actually, the dimensions are not at all going to change the elastic behavior. Their elastic behavior is going to be same. Right, तो हमेशा याद रखेंगे, nature of material and temperature are the two parameters based on which modulus of elasticity changes, but it does not depend on dimensions of the material. Right, now next is corresponding to 3 types of strain which we have done earlier. There are 3 modulus of elasticity. We define different modulus of elasticity for different strain. We have Young's modulus, then bulk modulus and modulus of rigidity. Right, Young's modulus, bulk modulus and modulus of rigidity. So this Young's modulus is basically defined for longitudinal stress, and this bulk modulus is defined for volumetric stress. We will see these things in detail. So let's move forward and let us first see Young's modulus. So as I have told you, Young's modulus is defined for your longitudinal stress. So how we define it? We know modulus of elasticity is what? It is strain divided by stress. So how we define it? So it will be it will be stress divided by strain. It should not be strain by stress. It should be stress by strain, because stress is equal to E into strain. So it will be stress divided by strain. So, how I am going to write my longitudinal strain? Longitudinal strain we know is delta L by L. And how I write my longitudinal stress? It is force per unit area. And force, which force? The restoring force, not the deforming force. But for numerical calculation, we know restoring force and deforming force are equal, right? So how it is going to be? If I substitute the values, what I'll get? I'll get F by A into delta L upon L. So this is my Young's modulus and it is represented by letter Y, right? So this is Young's modulus, right? So Young's modulus is modulus of elasticity in particularly for longitudinal stress and strain, right? Now, if I have to define modulus of elasticity for volumetric stress and strain, how we define? We define it by a letter K and that is called Bulk's modulus, right? And Bulk's modulus of elasticity is given by, we know it is delta V by V, but rather it would be force per unit area. It should be force per unit area divided by change in volume upon volume, right? Now this force per unit area is what? This is stress and this delta V by V is what? Change in volume. But here we take a negative sign because we know this time volume is decreasing. To compensate for that decrease, we take a negative sign. And also we know this volumetric stress generally is defined for liquids and for gases. And for liquids and gases, we know what is force per unit area. We define this term as pressure. So we can modify our expression as negative of P into V by delta V, right? So this is the expression for Bulk's modulus, right? This is the expression for Bulk's modulus. It is negative of P into V by delta V, right? Alright friends, let's move forward and we know this thing that P is pressure, delta V is change in volume and V is volumetric, right? Now let us define the third type of modulus and that is modulus of rigidity. Now this modulus of rigidity is basically defined for tangential stress and strain, right? So how we define it? We define it as tangential stress, which is what? Force by area, but this time area, which area we have to consider? We have to consider this area on which force is acting. We don't have to consider the normal area. This is important thing. Divided by, and we know how we define strain. We define strain as phi. That means this angle, or you can take it theta, because here we are using theta. So take it theta. So it is the angle theta which we have to consider. Force per unit area divided by theta. So it will come out to be F by A theta. Right? You don't have to remember these formulas. All you have to remember is that modulus is what? Modulus is stress divided by strain. And corresponding to the situation, you can easily find the stress and you can easily find the strain. You just have to take the ratio of the two things. Stress divided by strain. Right? So I hope now you are clear with different modulus of elasticity. Right? So let's move forward and let's see a very important curve, and that is stress strain curve. That means here what I am doing is I am plotting stress on y-axis. I am plotting stress on y-axis and I am plotting strain on x-axis. Right? This is stress versus strain curve. Now we know stress and strain are directly proportional to each other. Right? As per the Hooke's law, stress and strain are directly proportional to each other. Stress is proportional to strain. Right? But there is a limitation. This proportionality holds only in a particular region, and that region is elastic region. You remember I have explained the elastic limit. So it is only for this limit, under this limit, that this relation holds. That means this relation holds only under elastic limit. Now you can see this is my elastic limit. This E represents the elastic limit, and in this limit my stress is proportional to strain. You can see stress is proportional to strain, and if this is assumed to be a straight line, then what will be slope of this line? Slope will be stress divided by strain. Stress divided by strain. And what is stress divided by strain is? In actually, it is nothing but modulus of elasticity. That means in elastic region, the slope of stress strain curves gives us what? It gives us modulus of elasticity. That means tan theta will be equal to what? Modulus of elasticity. Because we know straight line, if there is a straight line, then slope of straight line will give me what? It will give me modulus of elasticity. But again, this is valid only if I am talking about elastic region, because after elastic region, that means in plastic region, the behavior changes. In plastic region, this relation do not hold, right? In the plastic region, stress and strain will not be proportional to each other, right? So I hope you have got the idea of this curve, stress strain curve. You have got the idea of elastic region and plastic region. These all things are we have discussed earlier in our previous sessions as well. So this is just like a conclusion of what we have done so far, right? So let us say when the strain is small, region OP proportional to strain, proportional to stress, right? It should be stress, right? Initially, when stress and strain are small, they are proportional, right? That means within this limit, elastic limit, right? This is the region where so-called Hooke's law is obeyed. Hooke's law says that stress and strain are proportional. That means it is in this region Hooke's law is valid. Sometimes you get a question like this: Hooke's law is valid in which region? It is valid only for elastic region. It is not at all valid in plastic region, right? So let's move forward and let's see. The point P is called limit of proportionality, and slope of line OP gives Young's modulus. We know this OP gives, slope of this line OP gives what? It gives modulus of elasticity of the material, and Y is equal to tan theta. This is also we know, right? Because tan theta is what? Slope of this curve, right? Now, next is point E is known as elastic limit or yield point. Now, this is something which you have to remember. This point E is called yield point. Yield point means after this point, body is not at all able to regain its original shape, right? So this is called yield point, right? Now, between E and A, strain increases much more, right? This is not something that much relevant. All you have to deal with is the elastic region. But just for the sake of information, you should know the region EABC. EABC represents the plastic behavior of the material of the body. And what do you mean by plastic behavior? Plastic behavior means the body, when the body do not regain its original shape. That is plasticity or plastic behavior of the body, right? So, based on these things, I hope now you are able to relate how stress and strain are related to each other, right? Next thing is, let's see some of the factors which affects elasticity of a body, right? So, if we talk about hammering and rolling, so hammering and rolling is one thing which increases the elasticity of a body. That's why if you have visited a factory, generally the tendency is to roll and roll more and more, right? जितना ज़्यादा हम roll करेंगे किसी भी object को, more will be its elasticity, right? Therefore, more and more rolling is done before giving a final product. We do a lot of rolling, and it is because of that rolling that elasticity of the body increases, right? Then the next factor on which it depends is the annealing, right? Annealing is again one factor which again increases the elasticity, right? Annealing results in decrease in elasticity of material, right? So because of annealing, elasticity decreases, right? You have to remember this thing. Now, next is the temperature. Temperature we know. elasticity decreases with rise in temperature, because we know, you can relate it, when we increase temperature of a body, there is a tendency of body to melt down, and if a body is melting down, its elastic behavior will for sure decrease, its elasticity will decrease, right? But in case of alloys, there is a the effect of change in temperature is very less, right? The effect of change in temperature is very less, right? Then if you talk about impurities, the type of effect depend upon the nature of impurities present in the material, right? With impurities, elasticity may increase or it may decrease. It purely depends on the nature of impurity. All right. So these are some of the factors which affect elasticity. So with this note, we are done with the part of stress and strain. I hope you must have enjoyed this session, and in our coming session, we will see some more beautiful concepts of physics, and we will see the effect of liquids. We will discuss about liquids. What is the effect of on liquids, right? So till then, keep learning and keep sharing. Thank you.